Yes, yesterday we have discussed the concept. Today we are going to see the problems. Here we have given a question that express the following statements into symbolic form. Means these three questions we need to express in form of symbolic form. By making use of this given three statements P, Q, R. In P, Ravi does not study this evening. Q, Ravi visit a friend. R, there is a cricket telecast. Now we are going to convert these three statements into the symbolic form. Now, to convert to symbolic form, first we need to identify the connectives, which yesterday we have discussed, like and, or, if and only if then, those all we need to highlight first. So, by highlighting them, we can make symbolic form easily. Here if is there. In this sentence again then is there. So, first underline those. If, then. Here also. If is there, then is there, and is also there. Here also. Here but is there, and again and is there. The reason why I underline but I will explain when we come to this statement. First we will see this. If Ravi does not visit a friend this evening, it is similar to which of the statement? Q, right? In Q what we have written? Ravi visit a friend. Here does not visit. Means simply what can we say? This entire statement is negation Q. And now he studies this evening. It is similar to somewhat P. In P what is there? Ravi does not study. But here it is there study. So it is negation of the statement P. So negation P. If negation Q, then negation P. How we represent if then? Using implication symbol. First statement negation Q and second statement negation P. Yes, this is the symbolic representation of the given statement 1. Now similarly for statement 2 and 3 we will solve. If is there. There is no cricket telecast this evening. What is our? There is a cricket telecast. Here no cricket telecast. So we can say it as negation R. Then Ravi does not study. As is it is there. So this becomes statement P. And visit a friend this evening. Visit a friend is also it is there. Q. Now how to take it? You need to observe first what it is there. If negation R. If is there, so you keep this implication symbol. Then means this complete one from Ravi to evening we will include this second statement side. And in first statement side it is negation R. So it is negation R implication. What is there in this complete thing? It means inside the then what it is there? P and Q. P and Q how we represent? Reverse V symbol. You use the brackets. This is the representation of second statement. And coming to third statement, why I underline but now I will explain. See, there is no cricket telecast this evening, but Ravi does not study. You leave this one apart. We can also modify this sentence as how? There is no cricket telecast this evening and Ravi does not study. So, as yesterday we have discussed, and is also called conjunction and or is called as disjunction. And for and we can use but also. Don't confuse for it. Now we will see. There is no cricket telecast. Means negation R, that is. Negation R. But is there. Means inside and. Now from here it will be entirely the second statement. Yeah, what is second statement? Ravi does not study. Ravi does not study. Write P as this. Again and is there. Does not visit a friend. Means negation Q. This is the representation of the given three statements into the symbolic form. Make a note of it. And they will also ask, they will give symbolic form and they will tell us to find the statements. That I will be explaining after this. Please make a note of it. Yeah. Now we need to convert this symbolic forms in form of sentences using this. Why I have written this formula, first I will explain it. This is what if P if and only if Q representation. I said another name for this if and only if symbol. It is nothing but by implication. By implication, by name itself we can say that double implication. P to Q and Q to P. That is what we represented here. It is equivalent to P implication Q and Q implication P. Why I have written is, while expressing in terms of sentences, you should not write directly if and only if. You need to make use of it and elongate the sentence. Now first I will explain this one. P if and only P, if P, then Q and R. First, if P. What is it? If P means a circle is a conic. If a circle is a conic, now completely this one we need to represent within then. Then Q and R. Root 5 is a real number. Then root 5 is a real number. Now what symbol we are having? And R. Minus 5 is an integer. This is for first one. Next, coming for second one. As I told you, I have to split this if and only if in terms of that. What does this one implies? This is nothing but negation P implication Q and Q implication negation P. This is what the second question means. Now we need to form the sentence using this one. Don't mention if and only if in the sentence. First, negation P implication Q. If, what does negation P mean? A circle is not a conic. Since P means a circle is a conic, negation P not a conic. If a circle is not a conic, then what is Q? Root 5 is a real number. Then root 5 is a real number. Don't keep full stop here, it becomes wrong. Because since we are splitting here, still this one also we need to elongate. This symbol indicates and again if Q now. What does Q? Root 5 is a real number. If root 5 is a real number, then negation P. Then a circle is not a conic. Like this we are going to work with problems, and still there are few important concepts that are nothing but inference rules, and those we are, before discussing those we need to discuss few laws like De Morgan's law, commutative, associative, distributive. Those laws we are going to see. First make a note of it. Yeah, now we are going to discuss about these 9 important laws which are very much important in this throughout chapter. But before starting, I want to tell that we mostly use or and only in these laws except few laws. The reason why is, if we take implication, let us consider P, Q, P implication Q, Q implication P, right? Now take values, truth values, true, 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 false, false, true, false, false. If we do like this, we get for P implication Q. For Q implication P, like this we are going to get. So here itself we are saying that it is not commutative. If it is not commutative, it even does not satisfy associative property. So we are going to work with or and only mostly. And these two laws are very much important. Law of implication laws and De Morgan's laws. First we will come from top, commutative. Nothing but P or Q is equivalent to Q or P. Because in or at least one is true, we will get the true. It can be either statement 1 or statement 2. So we can write anyhow. Similarly, P and Q is similar as Q and P. This is what commutative law. Next, similarly, when we come to associative, there we take three statements. Commutative is done. Now associative. P or Q or R is similar to P or Q or R. This is one, and one more also I will explain. Similarly, and also. Here, remember that in associative, both symbols must be same. I will explain the difference between associative and distributive here itself. Implication. P and Q and R. There is no variation in this both. We will get the similar. This is what associative. Now coming to distributive. Now distributive. Here you take different symbols. For example, here you keep and here you keep or. What will be the resultant? By distributive law we get P or Q, and since we are doing P with Q, P with R, in middle and symbol will be as this P or R. Here similarly P and Q or P and R. This is what distributive law states. Three laws we have completed. Next coming to double negation. For this with truth table I will explain. Here as I already explained, in case of negation we consider only one statement. So P. Since they said double negation, first do single negation, means negation P, and double negation, it means negation of negation P, which is nothing but P itself. I will explain it with truth table. P, negation P, negation of negation P. This is known as double negation. If P is true, negation P become false. Negation of negation P means negation of false is true. Here if you take false, true, here again we get false. Since these both are similar, double negation is nothing but itself the given statement P. This is what the representation. Next coming to implication. Implication loss. P implication Q can be written as negation P or Q, and if negation of P implication Q, we get as P and negation Q. This is what implication loss. These are very much important and we use in inference rules and predicate logics even. So first make a note of it up to implication. Yeah, now next coming to De Morgan's laws. Yeah, in De Morgan's laws we work with negation. That thing but negation of, if you take P and Q, negation of P and Q and negation of P or Q. What will get? Negation P, and when negation comes, this and becomes or negation Q. Here opposite, negation P and negation Q. This is what De Morgan's laws. Don't confuse for implication and De Morgan's laws, as these are very much important in case of inference rules. Next we are going to see idempotent. Idempotent is nothing but itself. We are working and or with the given statement itself, means only one statement we are using P. P or P, nothing but P only, because if it is true, it is also true. True or true means true only we will get. So since similarly for we can also say this also. P and P is also nothing but P. This is what idempotent law means. Next, coming to complement. Complement means what? We are going to work with P and complement. Negation is also called as complement, guys. P and negation P we are going to work with. Coming to P or negation P, what will be the resultant? Yeah, if P is true, let P be true, then negation P is false. If this is false, it will be true, right? In our truth table we have seen, if at least one truth value will be true, resultant will be true. So P or negation P will always be true. Similarly, if we do for AND, P and negation P, what does it mean? If this is true, this will be obviously false. If this is false, obviously it will be true. If both are true only, the resultant will be true. But we are not getting such case, right? Both are opposite. So it will be always false. This is what complement law states. Next, the last but nothing, identity law. Yeah, in identity law, we are using one statement with the Boolean value. Means P along with true we use, along with false we use. When we do P or true, with what will be the resultant? At least one is true, it will be true. So this will be true. Next, P and true. When P and true, we can't say true, because if suppose P becomes false, then it will also become false. Means this value is dependent on value of P. So we write here P. Next, similarly, for false we will do P or false. P and false. In or if at least one is true, then only it will be true. Here we don't know whether P is true or false. If P is true, then we get true. If P is false, then we will get false. Means this value is dependent on P. Again we will get here P. P and false. And in and if at least one is false, resultant will be false itself. This is what identity law. These 9 laws are very much important in case of mathematical reasoning. When coming to predicate logics, we mostly use implication and De Morgan laws. Hope you have understood. Now we are going to see about the inference rules. Everyone must make the note of inference rules, as that is very much important.